We're going to look at multiplying vectors. So in examples 4 and 5, what we saw was when we were adding vectors together, we just added the x components and added the y components, and that gave us the resultant vector of x plus y. When I subtract vectors, I subtract the x components and subtract the y components, and that gives me the resultant vector of x minus y. What I can now do is I can multiply vectors by a certain number. And what that has the effect of is if the number is bigger than 1, it has the effect of making it that many times bigger, depending on what it is. If the number is between 0 and 1, then it has the effect of making it that many times smaller. Okay? So if we were to go along vector A twice, the resultant vector would be vector A and then the same vector A. So we would call that vector 2A. Since we haven't changed direction, because the vector A is going in the same direction, vector 2A has to be parallel to vector A. They have to run in parallel to each other. Okay? So let's take a look at example 6 then. What we're going to do here is we're going to add the vector 2x plus 3y to this grid. So all I'm going to do is I'm going to double the x components. So for this vector, x, it was made up by going 4 along the way and then 1 up. So if I double that, I'm going to go 8 along the way and 2 up. Let's do that first. So go 8 along the way. 1, 2, 3, 4, 5, 6, 7, 8. And then 2 up. And that goes to there. So that there is vector 2x. To that, I'm going to add the vector 3y. So to get the vector y, I'm going 2 along and then 2 down. If I treble that, I'm going to go 6 along and 6 down. So I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6. And then 6 down the way. 1, 2, 3, 4, 5, 6. And that goes from there to there. And that is the vector 3y. So the resultant vector goes from the very beginning to the very end. It's the straight line that links the whole journey up and makes it into a triangle, that vector here, and that vector is going to be called the vector 2x plus 3y. Okay? And let's look at the components of that. The components of that blue vector is if I go along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then I'm going down 1, 2, 3, 4. So the vector 2x plus 3y has got components 14, 4. Let's test that out by working out the actual components of the vectors. So if we work out vector 2x plus 3y, the vector x was 4, 1. So it's 2 times the vector 4, 1 plus 3 times the vector 2 minus 2. So that would give me 8, 2 plus the vector 6 minus 6. So 8 plus 6 gives you 14. And then 2 plus minus 6 would give you minus 4. And that's exactly what we got there. Okay? Let's look at example 7 then. So we're not going to draw these out, we're just going to do what it says. So we're going to work out vector b plus c. So that would be 4 minus 2 plus minus 3, 5. So add the x's, add the y's, that would give you 1 minus 7. I've just realised my mistake. Clearly I can't add today. Let's try that again. That would give me the vector 1, 3. Okay? Let's look at b minus c. So vector B is 4 minus 2. Take away vector C, which is minus 3, 5. So 4 minus minus 3 is 7. Minus 2 take away 5 is minus 7. Vector 2b is just multiplying the vector b by 2. So it would be 2 times 4 minus 2, which would be 8 minus 4. Just multiplying all the numbers by the number on the outside. Next one, a half b plus 2c. So that's going to be a half of vector b, which was minus 3, 5. And then we're going to add on 2 times vector c. I'll start that again. Okay, so let's work out a half b plus 2c. So a half of b, so b is 4 minus 2. So it's going to be a half of 4 minus 2. Plus 2 times vector c, which is negative 3, 5. So this time we're going to multiply the components by a half. A half of 4 is 2. A half of minus 2 is minus 1. Plus 2 times minus 3, 5. 2 times minus 3 would give you minus 6. 2 times 5 is 10. So 2 plus minus 6 would give me minus 4. And minus 1 plus 10 is 9. Okay? Let's work out 5b minus 3c. So that's going to be 5 times the vector 4 minus 2. Take away 3 times the vector minus 3, 5. So that would be 20 minus 10. And then we would have minus, it would be 3 times minus 3, which would be minus 9. And 3 5s are 15. Keep the minus on the outside of the vector just now. So then 20 minus minus 9 would be 29. And minus 10 take away 15 would be minus 25. And then the last one, c take away c. So if I have the vector c, which is minus 3, 5, if I take away the vector c, which is minus 3, 5, minus 3 take away minus 3 is minus 3 plus 3, which is 0. 5 take away 5 is 0. So it's just going to be 0. And that makes sense, because if I have a random vector c, if I was to then go plus negative c, that would have the effect of going back down the way. And I would end up right back at my starting point. The vector is all about the journey. Okay?